So hello everyone, my name is Alexandre, or Alex, I don't know. You can call me whoever you want. Before we dive in, I want to share with you a little bit about myself. I have a simple blog, okay? Actually, I have two domains, and I am migrating the content from one to the other. The last one, the current one should be devcenterguys.com, and I have 8,000 views so far. I know it's a baby blog, but little by little, we are growing, okay? And I work as a software developer with Ruby, with Rails, for about 14 years. I've been working as a technical interviewer for about 1 year and a half. So I interview candidates who are applying for jobs in one American company. It's a freelance position. And now let's dive in and talk about. By the way, I want to share that I had one blog post I had a lot of views on this blog post, which is related to the performance using the Russian doll technique with Ruby on Rails. Yeah, I wanted to share with you. Anyway, so we are going to talk about implementing semantic search in Rails using vector databases. We are certainly thrilled by the power of large language models nowadays and the impact of AI in our professions and our society. And here, what we want to accomplish, we want to implement something to improve the user experience, okay? When, in this case here, since we are going to talk about semantic search and vector databases, we are going to start with the semantic search, okay? And let me show you, the semantic search is different from the traditional lexical search that we have, okay? By search, I'm talking about the search element that we have in our application, that the user is going to type something there and then it's going to bring results based on that criteria that the user typed. But this is the normal regular approach, which is the traditional approach. But here, what I want to share with you is the semantic way. It's also called vector search, that we are going to accomplish much more, not just that, okay? We have some characteristics of this traditional lexical search, okay? Well, the first one is the keyword based, okay? So whatever the user types, this is what we are going to try to match in the database, and then based on that, we're going to bring the results. I think it's pretty easy and everybody understands that. We can use SQL or maybe we can use Active Record to accomplish that. And let's talk about this part, this first characteristic, okay, keyword based. Let's suppose that our user wants to learn Ruby, okay, and then the user thinks, oh, I want to buy a book. The user talked to somebody and then this person said, look, you should go to the Amazon website and find a Ruby book. Oh, cool. This person doesn't know Ruby, this person doesn't know programming. The person wants to search for a book. The person goes to the website and then, okay, I'm just going to type Ruby here. And then the person types Ruby and then, what the heck? There is no Ruby book there. But this is correct because the search is based on the keyword and the keyword is correct. So as you can see, for example, here we have those results are related to Ruby, but this is not the Ruby that the user was interested in. And this is one characteristic that is very important because in the traditional search, the one that we usually work with, we do not consider the context. And when we talk about the semantic search, we're going to consider the context, okay? And then, okay. And then the user thinks, okay, no, the problem is because I didn't type Ruby and then I type book. I should type Ruby book and then I can see my results. And then boom, where's my book? My book is not there. So the user cannot find again the damn book. The damn book is not there. So the reason again is because there is no context involved. And this is one characteristic. The traditional search, the one that we work with, there is no context involved, okay? It's only based on keywords. Something else very interesting is the next characteristic, that we do not consider the intention of the user. Remember that we said that the user wants to learn programming. That's the intention, okay? I think everybody here knows one simple tool called ChatGPT, very simple. And when we want when we want to have good results from ChatGPT, we need to provide the context, your intention, and what you want. If you provide these three information, then you can get all the results that you want, okay? In theory. But again, the user now learned that his search was incorrect. And then, okay, let me try something. You know what? Now I'm not going to try Ruby, I'm going to try Rails. I think the problem is with Ruby. Ruby is cursed. Let me try Rails now. Okay, and then the user goes again to the Amazon website, and then boom, where is the book? Okay, the book is not there. Again, there's no context involved, okay? Keyword match, keyword base, only the keywords are considered here, and there's no intention. It doesn't matter if the user is looking for, okay, I want to learn programming, it doesn't matter here. What it really matters is only the keyword, it's only what you're typing. What we are going to try to accomplish here, we are going to try to bring results that are not only attached to the keyword. We want to try to bring results that are attached to the keyword, the context, and the intention. And we need LLMs in this case. And then the user is clueless. Let me put it here. Yeah. Okay. Another one. And then the user comes back, very sad, and then somebody tells him, you know what? Come back with Ruby now, but now you write the name of the damn book there. Okay, what is the name of the book? Type Ruby, polished Ruby. You know, this is the best book. If you type that, you're gonna get the result that you want. Are you serious? Yeah, purse. Go there. And then he goes there. What the heck? Only one result, man. So the fifth result is the book that the user is talking about, and all the other ones are related to stones, gems, and the ruby, you know. So we want to try to improve the experience of the user with the results, okay? Only keyword matched. No context involved, no intention involved in the traditional search, okay? That's the point. Since we don't have context, we don't have intention, their results are always going to be the same, okay? It might be good in a way because we can test, decorate tests, and then, but the results are going to be the same for everyone. We are not going to consider each person, okay? When we think about the semantic search, we are going to consider the difference between each person because every person has one intention and one context involved. Well, let's see. Think about this part here that we saw before. We can see that the user typed Rails, and then, as you can see, there are results that are not related to Rails programming, okay? When it comes to the traditional search, what would we do? We would need refine this query, okay? For example, we will need on the left pane, for example, we would need to create a checkbox with the name books, and then the user would click on the checkbox, the check, and then all books would appear, for example. And from time to time, we would need to create some refinements in order to bring the correct results to the user. So when we think about this traditional search, the one that we are using, we are usually refining this query and also checking for performance issues. Because everybody knows that when you search for something, in the database, there are a lot of associations and relationships involved. And you might get n+1 issue, or I don't know, or maybe you're hitting the database many times because you didn't code correctly there. And this is something that we need to check from time to time. When we go to the semantic search, the situation is going to be different. But that's okay. So we just wanna make the user happy, right? So now that we know how the traditional search works, let's compare a little with the semantic search, okay? So if the traditional search is based on keywords, semantic search is based on meaning, okay? We are gonna understand how this meaning is gonna work, okay? Because we're gonna work with vectors. That's why the name of the presentation, vector databases. So meaning, if you think about the word baby, baby is related in one way with person, for example, okay, or with puppy. It depends on the way that you see the correlation of words. So the semantic search we bring and we think about meaning, okay? And again, in this result that we got, that we typed polished Ruby, which is indeed the name of a book, a famous book, then the user would actually want to bring the results regarding the book and also maybe other books, related to Ruby or Rails or Sinatra or something else, but all things related to Ruby. This is the meaning involved. Context-based. When in the traditional search, there's no context, as we said. So the user only types what he's looking for, and then we are just going to check for that criteria that the user typed, and then we're going to check in the database. Only that. When we have the semantic search, we check the context that the user is in, and we also check the user intention, okay? Then we can bring results that are personalized, customized. We can bring results that are really relevant in this case. Now we think about something that is going to make the user happier, okay? And the last part, when we think, since we are bringing the results that are relevant to the user, now we don't need to perform so many query refinements, okay? It's not necessary to refine the query from time to time because we are considering we base on the context and the intention, okay? And then we have the results that we want. So, yeah. There's only something that I don't understand so far. Only something that I do not understand because I was preparing the presentation and then I went to Google, And then, I don't know why, some spirit came in and then I typed Java and then I saw all those sad people there, sad faces, man. People depressed, dying, I don't know. Maybe the semantic search is working, in this case, right? Because it's not keyword based. I'm sorry, but it's just a joke, but okay. Well, this is just one example, okay, in the point of view, in our point of view, that it's keyword based. This is one example with the traditional SQL, and then with active record, okay, that we have. So the idea is that we want the clueless user to find the correct information, okay? That's what we want. That's the idea. And now we know that semantic search has a lot to provide for us, okay? Using the power of LLMs. And now we go to the second part, okay? Now we need to understand how vector databases work in order to apply that semantic search, okay? We have a lot of vector databases nowadays, okay? They're different databases than the relational databases that we have so far, okay? They can they can work with vectors with efficiency, okay? And vectors are very important in this part, okay? Because all this information that we're talking about, for example, when the user types something there, we will pick up that information that the user typed, and we are going to convert into a vector, and that's the point. Because vectors, as we studied in mathematics, I studied a long time ago, but vector, or also called vector embeddings, okay, that's another name for it. They are a mathematical representation of data points in a multidimensional space. I'll give you one graph, then I'll show you guys one example that you can see it better, okay? And each data point that you will see in the graph is represented as a vector, okay? And each value has a specific feature or attribute of the data point. Let me show you here so that you can understand better the first graph, a two-dimensional graph, okay? This one is very easy to understand, and I think everybody remembers that we learned in high school, and probably some people learned in college. Here we have two dimensions, okay, of the graph. Every point in the graph has one attribute, one information, or one data. It doesn't really matter, okay? So, but every point represents something. And this is easy to see, and this is easy to work with. Even when we work in our paper, when we try to do the math, it's kind of easy to work with. This is another one with 2 dimensions, okay? Maybe it's better to see. But as you can see, all those points, they represent one data, one specific part, or one attribute, okay? That represent a piece of information. But we said that vector embeddings are multi-dimensional, okay? And this is the point. They are so big, there are so many dimensions that we cannot see with our eyes. We need a software because if I could have one here, I would need to change my hands so many times in an impossible way because we have so many dimensions. You know, here there are a bunch of dimensions there, and another way, it depends on the software, the way how we are gonna see this. It can become like this, you know. We can think about these multidimensional databases, vectors. We can think about this as when we select the color, for example, Paint or whatever app that we're using, that you have similar colors that you have to choose one, and then all the similar colors are together, if you think about. And this is one point, okay? Here is another representation. So every point there, this vector embedding, why are they important, okay? Because they're going to represent a piece of information that we are going to use and we're going to store them, okay? So for example here, I mean, it's hard to see, but all this information, all those crazy stuff over there in the middle, they are points, they represent attributes or things or data, okay? And let me show here one example, okay? Any information can be used, any data type can be used and can become a vector, okay? I don't know if you guys have ever tried other AIs there that you can upload an audio file or a video file that you can do a lot of stuff with different AI models, okay? There are a lot of stuff there on the internet. So in this case, what we are going to do, we are going to get that file. It doesn't matter what file that we are talking about, audio files or whatever, movie files or images. They're all going to be converted into vectors. And that's the point. When we have those vectors, that's how we are going to find similar things about those vectors, okay? When we think about those images there, here we can see images. We have a dog and a cat, and we can see that there are similar images regarding them. For example, when you see the cat, one point that the cat is there, and the point with the baby, you see a puppy, you see a cat on the left, okay? So it's a similar object regarding these two topics. Of course, here, what's the point? It depends on the context. That's why in LLMs, we are going to consider the context that we are involved and the intention, okay? That's the point. Okay, how it happens? How can we turn data, it doesn't matter what data, into vector embeddings, okay? Because we want to find similar results. We want to find good results that are really relevant to the user. Well, we have a bunch of unstructured data on the internet, okay? It doesn't matter what we are talking about. Today, there are so many possible things that we can do with data, okay? We have posts or images, video, audio, and anything you want. We want to turn those into vectors and store them in one place. The place is going to be called vector databases, okay? That's the place that we're going to store them. Why do we want to store them? Because we want to find similar results, or we might do something else, okay? In this presentation, we want to find similar results, but maybe we can do something else. I don't know. There is one AI that generates a movie or generates an audio, okay? So, but the first part is going to be, I have to store that, okay? How does it work? On the left part, we have the object there, okay? The object is going to be the data that we want to convert. This embedding model is that how large language models they come in handy, okay? Because they're going to convert that object, that data that we have, into vectors. Vectors are going to be, I can try to show you guys one, but it's gonna be a numerical representation just like that one, okay? Maybe they're usually bigger, okay? But it's like that way. Here I have another example, okay? Just showing the data types on the left, and then again the embedding model, which is gonna be one AI that is gonna do that and convert into vectors. And then at the end, as you can see, a lot of points over there at the end are the vector databases, okay, that they store those vectors. And according to the context or the intention of the user, that data can move, okay? So, because for example, if I think about Ruby in the context of programming and learning, I'm going, okay, so in this context, I want to bring books because learn is related to book, learn is related to this, and Ruby programming is a programming language. Then I'm going to bring results that are relevant. Okay, but if this is another person that is related to do something else, I want to buy stones, you know, the Ruby as a stone because I want to sell gems. So in this case, it's another context. So the result is going to vary. And this is something very important, okay? And we go to the last part, okay? Because the vector databases are the ones that are going to store those vector embeddings, okay? We're going to store them in order to have one search, for example, okay? Let me go this one here. Yeah. Let me show you here some possibilities, how we can find similar results, okay? Okay, so you guys saw that there's a multidimensional data over there. And then there's a lot of points and data points there, okay? As we saw here on the right. So in order to find similar results, we are going to provide a calculation, okay? And there are several different calculations that we can use, okay? Of course, I'm not going to dive into those options. And also, these are for examples. And every example has one possibility. But when we use the cosine or the dot product or the Euclidean distance, okay, these are ways that we can find similar results, data points that are closer to each other, okay? These are examples when we use mathematics, okay? Well, at the end, what is the complete process? We enter input data, okay? We want to search for something. We use one LLM in order to convert that data into a vector embedding. We're going to use, again, the LLM APIs to search for the input in the vector database, okay? So how are we going to implement this? Basically, we need one Rails application with input data. We already know how to do that. And we need one LLM in order to convert that data into vector embeddings, okay? But what else do we need? Let me show you more details, okay? Here, this is what we're going to use in a basic way. First, this is the end of almost the end, okay? First, we'll get an OpenAI key, okay, API key. This is one possibility because there are also other models that you can use on the internet, but I'm using this one because it's the one that I think it's easier and there are more examples on the internet. So you can create a new key, okay? Store your key in a safe and secret place, okay? I think it's usually better if you create an environment variable and use it there, okay? In this example, I'm gonna use one gem for this because I'm gonna put this API key there. Okay, I saved. Cool. Okay, we are gonna use the vector database that we're gonna use. Actually, we are gonna use Postgres, but there is one extension called pgvector that is gonna allow Postgres to work with vector embeddings, okay? So how is it gonna be? We create one application, a simple Rails application in a normal, regular way. We're going to use 3 Ruby gems here in this example, okay? The first and the second one, they work together. Neighbor is one gem that is going to find the similar results, okay? But neighbor needs the OpenAI in order to provide this, okay? So that's why we get the OpenAI key. And that Ruby gem related to OpenAI is gonna, make our life easier in order to finish this. We use the .env Rails gem in order to store the OpenAI key or whatever you want to store. Okay, it's an environment variable. The first migration is the one that we are gonna allow. We're gonna use pgvector with Postgres. It's very simple. We create a migration and then we put that code over there. Okay, we bundle install. In this step, we are just going to we're going to store the OpenAI key, okay, into an environment variable. Maybe this part, so far I think it's okay. This part, we're going to configure OpenAI key. We put it there, okay. Now we can create one Ruby code that is going to talk to the LLMs, okay. In this example here, I created one code, and this code is inside the services app. I created one services directory, and this is the complete code. There are basically two methods. One is chat interaction, and the other one is generate embeddings. Okay, so in one method that generate embeddings is going to turn the data into vector embeddings. Okay. And the first one is the one that is going to perform the search, that's going to check. Okay, so usually when we have, since we have this unstructured data, we usually use chunks, okay? We are not going to put the complete vector, the complete information in one specific record, okay? The chunk size, we can check the size of the amount of information that we can implement can be checked when you check the OpenAI API key, okay? That's one information. But here we're going to create a chunk model, okay? And the configuration is going to be like this, okay? As you can see, my vector is going to be 1,536, okay? That's the size of the vector. Okay, and now this is the configuration related to neighbor and OpenAI, okay? This part. And the last, yeah, I'm about to finish, and let me show you the last one, okay? Yeah. So the last one is, the last one, I mean, this is the last information in order to finish the presentation. The last one we're going to create the chunks in the, this is one example you test in the Rails console, okay? The last one we're going to create data, okay? We're going to generate data. And then when we perform down there the nearest chunks variable, it's going to rank the results based on the importance, okay? This is we are using the neighbor gem and the OpenAI gem, okay? And yeah, that's it. Thank you so much, guys.